Today we will talk about aliasing. What aliasing is? So suppose if we wish to measure a signal of 100 Hertz, what sampling frequency should we keep? That's the question. So we consult with Nyquist theorem, and Nyquist theorem tells us that your sampling frequency should be greater than 2 times your maximum frequency of interest. So 100 Hertz is our maximum frequency of interest. We have to measure 100 Hertz signal. So we have to keep our sampling frequency greater than 2 times your maximum frequency of interest. So we can keep the sampling frequency at 201 Hertz, 202 Hertz. We will measure the 100 Hertz signal. That's no issue, no problem. But as we know that some vibrations above 100 Hertz will also pass through because of the transition band of the filters. 105 Hertz pass through, 110 Hertz may pass. So assume that you have kept your sampling frequency 201 Hertz. Your maximum frequency of interest is 100 Hertz. So for 100 Hertz, 201 Hertz is very sufficient, no issue. But if a signal of 110 passes through, 110 Hertz, then will 201 Hertz sufficient for that 110 Hertz signals? No. For 110 Hertz signal, the minimum sampling frequency required is 2 times, greater than 2 times. So 110 Hertz, the sampling frequency should be greater than 220 Hertz, 221 Hertz, 222 Hertz. But we have kept the sampling frequency at 201 Hertz. So if a signal of 110 Hertz passes through, the sampling frequency of 201 Hertz will not be sufficient for that 110 Hertz signal. What will happen? Aliasing will happen. So for 110 Hertz, 201 Hertz sampling frequency isn't sufficient. So what will happen? Aliasing. So what we will see in the FFT spectrum? We will see an aliased peak in the FFT spectrum. At what frequency? At which frequency? That's the big question. So our sampling frequency is 201. Our signal is 110 Hertz signal which has passed through. So we will see a peak in the FFT spectrum at the difference of sampling frequency and your actual frequency. Your sampling frequency is 201 Hertz. The actual signal which has passed is 110 Hertz. So 201 Hertz minus 110 Hertz. We will have a peak at 91 Hertz. So 91 Hertz peak isn't real. It is an aliased peak, not the real peak. The real vibration is 110 Hertz signal. But it is aliased, it is being aliased due to less sampling frequency, and it is now being shown at 91 Hertz. There is no 91 Hertz vibration at the machine. 91 Hertz peak is the aliased peak. So if we keep the sampling frequency 201 Hertz and by somehow 110 Hertz signals passes through, that 201 Hertz will not be sufficient for that 110 Hertz, and we will see an aliased peak at the difference of 201 minus 110 is equal to 91 Hertz peak in the FFT spectrum. So we need to avoid aliasing, so that's why we keep the sampling frequency 2.56 times your F maximum, your maximum frequency of interest. So this is what aliasing is. Hopefully you have understand it, but if you have any question, do drop us a message. We will reply you and make you more clear about this concept. Thank you so much.